inertial frame and how we can use the Galilean transformation to understand the relative speed of the system. Here, but we can see that when we are using the Galilean transformation, then one observation, and that observation is that the speed of light is invariant from any inertial frame, which will be justified by what Michelson-Morley experiment is not going to fulfill. So obviously, Galilean transformation is one of the very smart way to discuss the thing. And even if at some point of time, at some level, it is not going to give the answer of all question of the nature. And obviously, we are talking about when our speed is approximately the speed of light. Then obviously, this is not going to work. Then obviously, what we have to do, we have to just go for a new theory, new concept, and that theory is given by what? A special theory of relativity. So let's try to go for the postulates of a special theory of relativity. And then we will go for what is Lorentz hypothesis and how we can derive the Lorentz transformation. And then we will try to solve different types of problems. Okay, so this is our main target. So just go for postulates of a special theory of relativity. This is all about postulates of STR, postulates of a special theory of relativity. Okay, now, so what will be first postulates? The first postulates of the special theory of relativity is all about the definition of inertial frame. So what we are just going to understand, we have to just talk about inertial frame. So first postulates is that there is nothing called absolute frame. Nothing called absolute frame. There is nothing called absolute frame. And if there is not any absolute frames, the frame is always relative. The frames are always relative, which is nothing but what? The outcome of definition of inertial frame from the Galilean transformation. The second postulate is that law of nature must be invariant, from any inertial frame. Any inertial frame. What is meaning of law of nature?
Speed of light is same from any inertial frame.
Obviously, that is third postulate. But what is in general meaning of law of nature? If you are writing Newton's law, F is equal to ma, the formation or formulation of Newton's law must be always same from any inertial frame. So either you are measuring the thing from S frame or S dash frame, F is equal to ma must be there. Maybe the value of A can be changed, maybe the value of F can be changed, but the formulation F must be equal to ma. The cause and effect must be preserved there. For example, in one frame, if there is conservation of linear momentum, then if we are watching the same experiment from the another frame, there must be conservation of linear momentum. ऐसा नहीं हो सकता है कि from one frame you can just go for conservation of linear momentum and from another frame you are not using the conservation of linear momentum. No. If frames are inertial, then obviously the conservation principle, law of nature, and whatever with the different type of law, Newton's law, that is the law F is equal to ma, is the law, and that law must be preserved. And third, last but not the least, the third thing is very interesting, and I have deliberately divided this third thing into two parts. The first part is obviously the speed of light. The speed of light must be invariant from any inertial frame. From any inertial frame. And the next postulates I can add it because we have already a special relativistic mass, and that is the part of my ASTR, so I can add it, and that is nothing but any materialistic particle. Any materialistic particle cannot achieve speed of light. What is meaning of any materialistic particle? What is meaning of any materialistic particle?
Particle which has a mass.
Which has mass. So if particle has mass, you can hold it, you can throw it, then it can never reach the speed of light. So materialistic particle have always a speed, and that speed is something alpha c, and alpha is between 0 to 1. So this can be the speed of any materialistic particle. So whatever we are going to discuss, or which type of, or whatever the problem we are going to solve, we have to take care of all these postulates, and we have to always make our formulation so beautiful such that these postulates should not be invalid. We have to obey these postulates because they are from the observation of nature. So every time you have to take care of postulates, you have to take care of assumptions. So these are our assumptions behind special theory of relativity. And now we will just go for the person named as Lorentz. He just give the remedies of all this observation when we are just approaching the speed of light, and he give the mind-blowing idea, and that turn all the concept of physics in another way. So what is his idea? His idea was very interesting and very simple too. So what is his idea? His idea was very interesting. Now, or obviously the genius people can always think simply. If people are genius, if someone is genius, he always thinks simple. He always think one of the fundamental thing. For example, Newton. Before Newton, you can see पेड़ से फल तो गिरते ही होंगे, सेब तो नीचे गिरते ही होंगे. But nobody observe it. Why it is happening? The great man observed this thing, so why he is great. Similarly, this person, Lorentz, will also observe the very simple thing, and he give the very mind-blowing idea. And how he have give this idea, I don't know, but I can tell you from my intuition that why he has taken this sort of mathematics. Now just tell me, when we started physics, what will be our first chapter? कौन सा टॉपिक हमने पहला चैप्टर में पढ़ा था?
Units and measurement.
यूनिट्स एंड मेजरमेंट्स, है ना, डायमेंशन, है ना. एंड व्हाट इज फंडामेंटल ऑफ द डायमेंशन? What is fundamental of the dimension?
Length, mass,
Obviously,
time.
the fundamental of a dimension is mass, length, and time. Obviously, we are talking about mechanics. When we will include electrostat, then Q will be also there. But we are just talking about mass, length, and time. If we are talking about kinematics, then leave the mass part, the length, and time. And now, Lorentz argue very nicely. What he said? He said that if from the one reference frame, the spatial part is going to vary, then what is the reason behind that your time is going to constant? If both are the fundamental thing, the length and time both are fundamental thing, then obviously from one reference frame, if we have different coordinates of space, then we should have different coordinates of time. He was broad-minded person. He was a risk taker, and he take the risk that what he can say, he just says that time is not going to absolute from one frame to another frame. This is a huge statement. This is the huge statement. And he also imagine a world, and that world is basically not a three-dimensional world. That is basically four-dimensional world. And he says that when thing is going to move, when there is dynamics, when there is kinematics, when thing is going to move, and if the speed of light, and if you are moving with a so fast, and you are moving so fast that you can approach the speed of light, something like 0.8 c, 0.9 c, then what is going to happen? You can see the time coordinate is also going to change with respect to one frame and another frame. This is mind-blowing idea. But yes, the fundamental is that, and this question can be easily asked, that if your length and time both are fundamental quantity, then why you are so much biased about space or length that it is going to change, and or the coordinate of a space is going to change, but the coordinate of a time is not going to change. And he opened this thing with the help of mathematics, and he just give the famous Lorentz transformation. So what should be the nature of Lorentz transformation? So let's first go for the basic nature of Lorentz transformation, or what should be the property of Lorentz transformation. This is very important. The property of Lorentz transformation. The property of Lorentz transformation. The first property is that this is my first property. And what is that property? That property is basically the transformation between x and t must be linear the transformation between x and t must be linear, or you can say that x and t to another x dash and t dash must be always linear because it will tell you the same event from two different frames. If this is going to happen, then obviously your transformation must be linear. So first thing, we have to take care of this thing. The transformation must be linear between position to time and time to position and time to time and whatever will the thing is there. Now, second thing is very interesting. If V upon C tends to 0, means the speed of a frame is approximately is very, very less than the speed of light, then Lorentz transformation must be reduced to Galilean transformation. Why? Because Galilean transformation is very efficient for the low speed system, for the Newtonian world. But Lorentz transformation, but obviously this Lorentz transformation must be equivalent to what? Your Galilean transformation. And third, last but not the least, if Lorentz transformation must be there, there must be inverse Lorentz transformation, ILT. Then must be inverse Lorentz transformation just by changing speed, changing the velocity s to s dash to what? Minus velocity of s dash to s, isn't it? S का S dash के साथ और S dash का S के साथ क्या relationship है? Only you can take this negative thing and you can just jump from one transformation to another one or another one to next one. So we should make a provision mathematically which follow these property and obey the postulates of STR. The first two postulates is very trivial for the inertial frame, but the last one is very interesting, such that speed of light must be invariant. So now we are just going to derive the Lorentz transformation. And you will see we will just use very simplistic way to derive it. In different book, they have just derived it in a very haphazard manner, but we will use just a simplistic derivation of Lorentz transformation. But before that, if you have any argument, you can let me know. Everyone is comfortable? If you have any counter view with rationality, obviously, then you are welcome to discuss.
Sir,
Yes.
sir, ये first postulate क्या है? मतलब must be linear.
मतलब x और x डैश के बीच में जो हम रिलेशनशिप एस्टेब्लिश करेंगे, दैट शुड बी लीनियर, जस्ट लाइक एज ए गैलीलियन.
Okay.
गैलीलियन में क्या था? x इज इक्वल टू x डैश प्लस vt, इजंट इट?
Yes, sir.
है ना? एंड दैट इज लीनियर वन. ये तो था, है ना?
Yes, sir.
ये क्यों लीनियर था? बिकॉज सेम इवेंट को दोनों बता रहा है ना, सेम पॉइंट को दोनों बता रहा है. यस,
Yes, sir.
आर यू गेटिंग माई पॉइंट? अगर वो डिफरेंट पॉइंट को बताते तो जरूरी नहीं होता कि वो लीनियर होता, उसके एक से ज्यादा रूट हो सकते थे उस इक्वेशन के, है ना?
Yes, sir. Yes. Got it,
Exactly.
sir.
Okay.
Sir,
Yes.
please, this third one also will you explain once again?
Sorry, this third one?
Yes, sir.
हाँ हाँ.
With but that आपने जो ये V S S dash वाला पार्ट समझाया ना, प्लीज एक बार उसे एक्सप्लेन कर दीजिए.
मैं ये कह रहा हूं, थर्ड वन में मैं ये कहता हूं कि अगर आपके पास लॉरेंस ट्रांसफॉर्मेशन है तो इनवर्स लॉरेंस भी होना चाहिए. आप और लॉरेंस से इनवर्स लॉरेंस जाने के लिए आपको कोई कैलकुलेशन करने की जरूरत नहीं है. व्हाट यू हैव टू डू, यू हैव टू ओनली चेंज द वेलोसिटी ऑफ एस वर्सेज एस डैश और को माइनस एस डैश वर्सेज एस से चेंज कर देंगे, है ना, जैसे गैलीलियन में किया था.
Yes sir.
आपको याद है गैलीलियन में किस तरह
Yes,
से
sir.
किया था, है ना?
Yes sir.
सो दैट इज द सेम थिंग. वो तो ओबे होना चाहिए ना.
हाँ sir.
सो उसी का फायदा उठा करके हम लॉरेंस ट्रांसफॉर्मेशन को डिस्कस करेंगे. ओके
Yes sir.
ओके गुड. सो लेट्स ट्राई टू गो फॉर अ डेरिवेशन ऑफ लॉरेंस ट्रांसफॉर्मेशन. ओके ओके देखो, शुरुआत के 2-3 क्लास हमें स्लो रहना है, आज की क्लास और कल की क्लास. एंड वंस दिस 3 क्लास विल बी ओवर, then you can solve each and every problem and then we can just अपने आप को पुश कर सकते हैं. ओके बट इनिशियली यू हैव टू अंडरस्टैंड द बेसिक कॉन्सेप्ट, सो व्हाई यू हैव टू बी लिटिल बिट स्लोअर. सो नाउ लॉरेंस गैलीलियन ट्रांसफॉर्मेशन में हमने सबसे पहले क्या डिफाइन किया था?
Frames.
एस फ्रेम डिफाइन किया था, एंड दैट फ्रेम मस्ट बी व्हाट? Inertial in
Inertial.
nature. So same thing we are going to do also here. So this is my S frame and there is origin and there इसके बाद हमने क्या डिफाइन किया था?
S dash frame.
S dash frame. And this S dash frame has velocity. What is that velocity? V in I cap direction. Okay. And velocity of S dash with respect to S is equal to V in I cap direction. Deliberately हमने I cap direction क्यों लिया था? Because we know they are inertial frame और inertial frame हमेशा क्या होगा, एक ही डायरेक्शन में मूव करेगा और जिस डायरेक्शन में वो मूव कर रहा है I will deliberately choose it I cap, isn't it? Now फिर थर्ड हमने क्या डिफाइन किया था?
Point P.
पॉइंट P. हमने थर्ड डिफाइन किया था, that is what? Point P. So now this point is X, Y, Z, and now time T is also there. From which reference frame?
S frame.
S reference frame. And the same point is X dash, Y dash, Z dash. लेकिन यहां तक तो गैलीलियन के साथ थे हम, but after then Lorentz dared to write this thing. ये किस फ्रेम से देखा हमने?
S dash.
S dash फ्रेम से देखा. एंड ऑब्वियसली रिलेटिव स्पीड किस डायरेक्शन में है? ओनली इन एक्स डायरेक्शन में. सो तो जो भी चेंजेस होगा वो हमारे किस डायरेक्शन में होगा? दैट विल बी इन एक्स डायरेक्शन. ओके सो एक्स इज मोर सिग्निफिकेंट. नाउ what is meaning of t is equal to 0? These two are going to coincide, isn't it?
Yes, sir.
Now, when these two are going to coincide, what is going to happen? A light pulse will emerge in a x direction. Light pulse emerge हो रहा है x direction में. Clear है ये कहानी? So, when you have this situation, meant S and यहीं पर S dash है, so light pulse is emerging in a x direction. So what will be the speed of light pulse? C. Okay. Now, and obviously Lorentz used the concept of Galilean. So he never discarded Galilean. So this is the good thing for the big people. They always respect each other and they just try to improve the version. Same thing Lorentz also did. He just tried to improve the version. So what is that particular thing? Look at here. So I can write x is equal to x dash plus v t dash. Now look at here. Look at it. It's a very interesting. In a Galilean, x dash plus vt. Everyone is comfortable? So what will be the independent variable and what will be the dependent variable here? What is independent variable into this one?
X dash.
X dash and t. Okay?
Dependent is X.
And dependent is x. So now, if we are putting t dash here, then what should be the independent here? The frame, the variables we are using from the s dash frame, isn't it? है ना? Are you getting this one?
Sir, please repeat.
आप समझ रहे हो? फिर से मैं बोल रहा हूं.
नो सर
Look,
ये
think.
दोबारा बताओ।
समझने की कोशिश करो. जो मैं राइट साइड की तरफ लिखता हूं उसे डिपेंडेंट कहते हैं या इंडिपेंडेंट कहते हैं? इंडिपेंडेंट कहते हैं. तो यहां पर जो इंडिपेंडेंट है, दे आर फ्रॉम एस फ्रेम और एस डैश फ्रेम.
एस डैश
S dash.
एस डैश फ्रेम. गुड. नाउ वी हैव टू राइट दिस थिंग अकॉर्डिंग टू लॉरेंट्स. सो इंडिपेंडेंट आप एस फ्रेम वाला लिखोगे या एस डैश फ्रेम वाला लिखोगे?
S dash.
S dash. So position is x dash. And what is your independent time? T dash.
यस
Yes, sir.
Logic समझ में आ रहा है ना? So, and there is one correction term, and that correction term is, let's say, gamma. And this gamma will be equal to 1 when we will go for when v upon c tends to 0. And t dash must be equal to t. So this is basically known as what? Inverse Lorentz transformation. Now, can you write the Lorentz transformation from here?
यस सर
क्या होगा जरा बताओ?
एक्स डैश
X dash is equal to,
गामा
very good, gamma तो gamma ही रहेगा,
हाँ
है
जी
ना? Very good. Then
एक्स
x,
Minus.
प्लस माइनस वी
that is plus minus v into t. Exactly. Very good. Very good. Excellent. So what will be your x dash? Your x dash is equal to gamma x minus vt. लिख सकते हैं ना? Obviously, conceptually you are 100% correct. Now, please look at here. At the same point of time, दोनों के लिए t is equal to 0 हमारा क्या है? Same है ना? So now, if I am going to watch this speed of light from S frame, then x upon t must be equal to c. ये हम किस फ्रेम से देख रहे हैं?
S frame से.
S फ्रेम से. इसी चीज को आप अगर S डैश फ्रेम से लिखोगे तो क्या होगा?
X dash upon T dash is equal to.
Exactly, x dash upon t dash must be equal to c. If right hand side is going to constant, तो कितने बेसिक मैथमेटिक्स है, कितनी बेसिक लॉजिक है. दिस इज ऑल अबाउट द रेशियो. अगर राइट हैंड साइड की बात अगर कांस्टेंट है, आप अगर सिर्फ x को चेंज कर रहे हो तो ये कभी पॉसिबल हो पाएगा?
No, sir.
Never, never. So we can use this concept here. Now look at the derivation. It's a wonderful derivation. हम क्या कर रहे हैं? दोनों को मल्टीप्लाई कर रहे हैं. So we are just going to multiply x dash. This is your equation 1 and this is your Lorentz transformation. This is your equation 2. Just you are multiplying both sides. So there is gamma square. होगा ना? And where is x dash x? फिर से क्या हो जाएगा? This into this is also there. So what will be? V square t dash t. Then Cross term is also there. Minus x dash v t. Cross term is also there. Plus x dash v t dash. Sorry, x v t dash. x v t dash है ना? x v t dash. देखो मैंने सही किया है या नहीं? Just check it. सही लिखा हूं?
Yes, sir.
Okay. Now, what we will do, we will just divide x dash on both sides. So this value is 1. Gamma square is there. 1 minus v square t dash upon x dash and t upon x. मैं deliberately symmetry में लिखने की कोशिश कर रहा हूं. And you have v x dash और x dash cancel हो जाएगा. Then what you will get? T upon x plus what you will get from here?
T dash upon x dash.
T dash upon x dash. Very good. Now, what is T dash upon x dash?
1 by c.
I see.
Very good. So this is minus v square into 1 by c. What is T upon x?
1 by c.
1 by c minus what is T upon x? V upon c plus what is T dash upon x? V upon c. These two things cancel out and you can have value of gamma, and we are deliberately taking it as a positive, that is 1 minus v square upon c square. And now you can see if v upon c tends to 0, then gamma is equal to what? 1. हो रहा है ना? And now I am giving you homework to find the t dash. कैसे आप find करोगे t dash को? Now you can put value of x dash here. यहाँ लिख सकते हो? Just use this homework. I am just giving you that what should be the concept. I can write x dash here. लिख सकते हैं?
Yes, sir.
Okay. Once you will write x dash here, then you can easily find the relationship between t and t dash. मिल जाएगा हमें?
Yes, sir.
Okay. So just go for your homework, and this is a very nice exercise. Okay. So आप इसको एक बार try करो. I am just writing directly what will be the Lorentz transformation and what will be inverse Lorentz transformation, and then we will try to prove that the speed of light is invariant. Okay. इसको हम लोग prove करने की कोशिश करेंगे. Everyone is comfortable up to this point? So what you will get? You will get x dash is equal to x plus vt by root under 1 minus v square c square. Y dash is equal to y. Z dash is equal to z. And t dash is equal to t plus vx upon c square root under 1 minus v square upon c square. This is very famous Lorentz transformation. And what is x, y, z and t? What is x, y, z and t?
In a
For-
S frame.
From S frame.
Variables in a
They
S
are
frame.
the coordinates from the S frame. Okay? They are coordinates. Coordinates. Okay? That's a point. Now, what should be the inverse Lorentz transformation? आप जरा बताओ. If you can write Lorentz transformation. Sorry, एक मिनट कुछ मैंने गलती लिखा है. This will be negative. Sorry. This will be negative. Just check it. This will be negative. है ना? What will be inverse Lorentz transformation?
X is equals to x
Yes.
dash
X is equal to x dash. This minus we will change to what?
plus
Plus
vt.
vt t dash actually
Oh.
by root under 1 minus v square c square. y is nothing but y dash, z is nothing but z dash, and t is nothing but t dash. What will be this one? After then? Plus v
x dash
x dash
upon
c
c
square root under 1 minus v square upon c square. Now you can see, is that transformation between x and t is linear? Say yes or no?
Yes, sir.
Yes. Is that when v upon c tends to 0, t is equal to t dash? हो रहा है? Yes. If v upon c tends to 0, then t is equal to t dash?
Yes.
Yes. If t is equal to t dash, then your transformation will be transformed to Galilean one. Are you happy?
Yes, sir.
Yes. That means we are into the correct path. हम लोग क्या है? Correct path में move कर रहे हैं. Okay. So this is the coordinate transformation, which is basically linear coordinate transformation. कैसा coordinate transformation है ये? Linear coordinate transformation. Okay. But actually में ये क्या है? क्या ये किस तरह का सिमेट्रिक के बारे में बात कर रहा है? ये हम लोग लास्ट क्लास में देखेंगे. When we will go for what? Minkowski space. But before that, what is the real challenge? Real challenge क्या है? ये ट्रांसफॉर्मेशन हमारा सही है या गलत है? ये कैसे प्रूफ होगा?
C plus V जो आ रहा था
वो C आना चाहिए, isn't it?
आना चाहिए.
Okay. So first हम लोग without using relative speed देखते हैं how we are going to use Lorentz transformation, and then we will find then we will prove it from the relative speed also. But let's try to use the Lorentz transformation and just try to see how your speed of light is invariant from two inertial frame. यहाँ तक clear है ना? Okay. So there is a train. This train is, and there is a source of light. Let's say this is source of light, and there is a detector. Okay. And there is one observer standing on a train. Let's say this observer is X. The length of train is L. And there is a platform. There is another observer who is Y. Okay. The light pulse will come from S and it will go to D. So what we have to do? We have to calculate delta X, means what is the distance. इसको A और B कर लो, है ना? A कर लो और B कर लो, otherwise थोड़ा सा problem हो जाएगा. And this is just moving in X direction. Okay, so what is delta X? Delta X with respect to A, and then we have to calculate delta T with respect to B. Okay, by assuming that the speed of light is C. Sorry, delta T with respect to A. And then we have to calculate delta X with respect to B, and we have to calculate delta T with respect to B. And we have to also calculate delta X with respect to B by delta T with respect to B. ये क्या आ रहा है? ये हम देखने की कोशिश करते हैं. ठीक है? Okay? So let's try to go for this. I can assume this is my S frame. So this will be what? My S dash frame. Clear है ये? This is my S frame. So this is my S dash frame. And this is moving with velocity V in I cap direction. This is also moving in I cap direction. So velocity of S dash with respect to s, इसे मैं क्या लिख सकता हूं? v लिख सकता हूं ना? I cap direction, this is given. Now what will be delta xa? What will be delta xa? कितना डिस्टेंस ट्रेवल करेगा स्पीड ऑफ लाइट?
L.
L. Okay, distance between source and detector is L. How much time it will take?
L by C.
L by C. Very good. This is straightforward. Okay. Now, can I write this delta XA as X2 dash minus X1 dash is equal to L? This is nothing but the distance between two coordinate. Yes or no?
Yes, sir.
And this is from the S dash frame. So I can write it this one. This is nothing but delta XA. Yes. And what will be delta TA? Can I say this is T2 dash minus T1 dash, that is L by C? Can I write this thing in our notation?
Yes, sir.
Okay. So this is from which frame? S dash frame. And let us try to go for S frame. What is delta XB? Can I write X2 minus X1? जो यहां से A से डैश दिख रहा है, यहां से क्या दिखेगा? X2 माइनस X नॉन डैश दिखेगा? Yes या no?
Yes, sir.
Yes. So we can use Lorentz transformation from here. लिख सकते हैं ना? Can I write this thing as X2 dash plus V T2 dash upon root under 1 minus V square C square minus X1 dash plus V T1 dash root under 1 minus V square C square? देखो ऐसा लिख सकते क्या?
Yes, sir.
Because we are using the Lorentz transformation. ठीक है ना? And now I can take a space part together and time part together. So what will be space part? X2 dash minus X1 dash plus V, and नीचे तो यही रहेगा 1 minus V square upon C square and V by root under 1 minus V square C square. This is T2 dash minus T1 dash. Just check it. Just check it. Everyone is comfortable?
Yes, sir.
Okay. What is X2 dash minus X1 dash?
Delta XA.
Delta XA, that is L?
Yeah.
Isn't it?
Yes, sir.
Okay. So that will be L upon root under 1 minus V square C square plus V, and what is T2 dash minus T1 dash?
L by C.
L by C root under 1 minus V square upon C square. Okay. So I can write it in a little bit smarter way, and delta XA is nothing. I can take L common. So what I will get? 1 plus V upon C by root under 1 minus V square upon C square. Can I write this thing as L?
Sir, delta XB, na?
Delta XB. Okay, yes. Good. Delta XB. And that thing is nothing but I can take root part 1 plus V upon C, 1 minus V upon C. क्या ऐसे लिख सकते हैं इसे?
Yes, sir.
Yes? Okay. And this will be delta XB. So total distance traveled by this light pulse is more than L. है ना? Isn't it?
Yes, sir.
Okay. Now Let's try to go for calculating delta TB. यहाँ तक clear है आपका? So we are just going to calculate delta TB. So what will happen delta TB? बताइए क्या होगा? T2 minus T1, because this is from S frame. Again, we will go for the Lorentz transformation. So what will be T2? T2 dash plus V x2 dash upon C square root under 1 minus V square upon C square minus, so this is equivalent to T2, and T1 can be written T1 dash plus V x1 dash upon C square root under 1 minus V square upon C square. So we are using Lorentz transformation efficiently, isn't it? Now, again, what we will do? We will just take the time part together and the space part together. So what we will get? We will get, and this is your delta TB is equal to T2 dash minus T1 dash root under 1 minus V square upon C square, plus I can take V upon C square common, and this is x2 dash minus x1 dash root under 1 minus V square upon C square. What is T2 dash minus T1 dash?
L by C.
L by C. And this is 1 minus V square upon C square plus V upon C square. What is x2 dash minus x1 dash? L. And we have 1 minus V square upon C square. I can take L upon C common, and we have 1 plus V upon C and 1 minus V square upon C square root under. So this value is L upon C root under 1 plus V upon C, 1 minus V upon C. Everyone is comfortable right now? Now, just divide delta XB by delta TB. What you will get? जरा divide करो तो.
C.
C.
Delta XB by delta TB is equal to, delta XB is what? L root under 1 plus V upon C, 1 minus V upon C, L upon C root under 1 plus V upon C, 1 minus V upon C, and this is nothing but C. What you will get? What is the conclusion? What is final conclusion?
Speed of light is constant.
Speed of light is invariant. Either you are going to measure from S frame or you are going to measure from S dash frame. The speed of light is invariant, isn't it? And we have proved it with the help of Lorentz transformation, isn't it? जो स्पीड आपको ट्रेन से दिखाई दे रहा है लाइट की, वही स्पीड आपको अर्थ से भी दिखाई दे रही है. बट इन अ गैलीलियन हम लोगों ने क्या देखा था अर्थ से? लास्ट क्लास में हमने देखा था, क्या देखा था? V plus C. Remember?
Yes, sir.
Yes, sir.
But here we have find, and this is nothing but the speed of light from which frame? From the platform, nahi?
Yes, sir.
Yes, sir.
Okay, this is the speed of light from the platform. And we know the speed of light from the train is C, and we have proved that the speed of light with respect to platform is also C. Yes, Lorentz transformation works very efficiently. Okay, and we will use this transformation to redefine our relative speed, and we will then solve different type of problems based on relative speed. Okay. And what will be meaning of simultaneous if two event is happening simultaneous? What is meaning of that?
Same point of time पे
Same
Same.
point of time means T2 dash minus T1 dash is equal to what? 0.
0.
If they are happening on same space,
x1 dash minus x2 dash.
x2 dash minus x1 dash is equal to 0. Okay. So this type of problem will always in there. The two event is there. One will be at the same time from one frame, but it is not necessary that will be same time from the another frame. This kind of observation can be always there. And so why Lorentz transformation is very, very useful. And if you will see that for the high energy physics, whenever your speed is very high, this STR will come into picture. So STR, relativistic quantum mechanics, relativistic electrodynamics, these all are advanced topic. And we can use this Lorentz, the symmetry of Lorentz into our calculation. Why I am saying the symmetry of Lorentz? We will discuss it into the last class. Okay. When we will just understand the basic thing, then we will get matured and then we can discuss it. By the way, Lorentz transformation is nothing but what? Coordinate transformation. You have to always take care of this statement. Okay. So in tomorrow class, we will just try to prove the relative velocity and we will just make a way and make a algorithm to solve the problem in a same way. Okay. So I think I must stop here because it's already 9:05 in my watch. If you have any doubt, you can just quickly ask me. Otherwise, you can just ask into the next class.
सर इसमें टाइम टेकन भी बढ़ रहा है ना, मतलब लाइट
Yes, time भी बढ़ रहा है. Obviously, ये क्यों बढ़ रहा है? क्यों बढ़ रहा है ये? क्योंकि आप जो जमीन से देखोगे तो लाइट तो ऐसे जा रही है ना? और डिटेक्टर भी क्या हो रहा है, इस डायरेक्शन में मूव कर रहा है. Isn't it?
सर
तो इफेक्टिव टाइम और इफेक्टिव डिस्टेंस क्या हो जाएगा? दोनों बढ़ जाएगा, है ना? लेकिन ये आप कहां से देख रहे हो? ये वाला सिनेरियो आप कहां से देख रहे हो? प्लेटफॉर्म से. और अगर आप ट्रेन से देखोगे तो क्या देखोगे? लाइट जा रहा है बट ये रुका हुआ है ना?
यस सर.
सो ऑब्वियसली. लेकिन ये सिनेरियो आपका अगर v/c टेंड्स टू 0 कर दो तो नहीं दिखाई देगा, है ना?
फिर तो सेम ही आ जाएगा.
सेम ही आ जाएगा. यस. हम लोग इस तरह के बहुत सारे प्रॉब्लम सॉल्व करेंगे. डोंट वरी, वी हैव लॉट ऑफ एक्साइटिंग क्वेश्चंस, है ना, इन आवर बैग. सो वी विल सॉल्व इट. ओके, थैंक यू.
थैंक यू सर.
Thank you, sir.
Thanks, sir.
थैंक यू.
Thank you, sir.
थैंक यू.